Alright, so our next topic, we're going to be doing probability still with the binomial distribution. So on here, a binomial distribution can be thought of as simply a probability of success or failure outcomes in an experiment. Okay, so you have B equals, now we have a combination, but we still have to multiply our combination by the number of success, p to our power, and our failures, q to the n minus r. Where n is the number of events, okay, so it's kind of similar to what we were doing before. So n is the number of events. R is a number of favored events, okay, and then P is the probability of the successes, and we'll kind of go over it a little bit more. And then Q is the probability of failure, okay. So on here it says a fair coin is tossed 7 times. What is the probability to the nearest 1,000 of getting exactly 5 heads? Okay, so a fair coin is tossed 7 times. So the number of events we have is 7. So n is equal to 7. Then it says what is the probability to the nearest 1,000 of getting exactly 5 heads. So the number of favored events, so we want 5, okay? So R equals 5, because we want 5 heads. Well, what's the probability of getting a head? Okay, so that's going to be our P. The probability of getting a head is 1 over 2, okay, 1/2, okay, because you have a coin, both sides, one side's heads, one side's tails. So the probability of failure, which is Q, is also going to be 1/2, because if the probability of getting a head is 1/2, then the probability of getting a tails is the other half, okay? So we're going to go ahead and plug all this into the formula. So our binomial theorem is equal to the combination of n and r. So the combination of n, which is 7, comma r, which is 5. So we're going to put that in our calculator. Remember, this gives us a number, okay? And then we're going to multiply times the probability, which is 1/2, to the power of r, which is 5. And then we take the q, which is also 1/2, and it happens to be 1/2 in this problem, and we multiply it times n minus r. So our n is 7 minus r is 5. So 7 minus 5. Okay, which in that case it just gives us 2. 7 minus 5 gives us 2. So I'm going to go ahead and just replace that with the 2. All right. So let me go ahead and get out my Delta Math calculator. How do I get rid of this? Just put it up there. So functions, we have NCR. We have 7 and 5. So that gives us 21. Okay. So here, this gives us 21. So I'm going to go ahead and take the 21 and multiply times 1/2 to the 5th power times 1/2 to the 2nd power. Okay, so I'm going to go ahead and put all that in my calculator. So 21 times, I don't know how to get rid of, oh, there it goes. 21 times, parentheses, 1/2, close parentheses, close parentheses, to the power of, like, how do I move this thing? It's just in the way. Let me split the screen, that might be better. There. 1/2 to the power of 5. And then get out of the exponent times another 1/2 to the power of 2. Hit enter, and then this gives me 0.1640, and it's telling me here that I need to round to the nearest 1,000. Okay, so then that's going to be 3 decimal places, so it'll be 0.164. Okay, so let's go ahead and try another one. Okay, here it says if a fair die is rolled 7 times, what is the probability to the nearest 1,000 of getting exactly 5 3s? Okay, so we need to do the same thing. We have N is the number of events. So that means that we're rolling the die a total of 7 times, okay? Then it's asking us, what is the probability to the nearest thousands of getting exactly 5 threes? So then R here is 5, okay? So that's the number of favored events. We want to have 5 threes, okay? Now P is a probability. Well, what's the probability of rolling a die and getting a 3? So if you're not sure, we have a die. I'm not the best artist, but I will try my best to make a die. Okay. So the die, just in case you didn't know what it is, it looks something like this, and then it has like one dot here. Oh, wait, it's not coming out. One dot here, and then another side has 2. The other one has 3 dots, which is what we're favoring, and then there's another one that'll have 4. So there's a total of 6 sides on this, okay? So there's only one side that has 3 little dots, okay? So our probability is going to be 1 out of 6, okay? Now, the other 5 sides, we don't want them. That's not our favorite event. So Q is going to be 5 out of 6, okay? So then we're ready to plug all this into our binomial theorem or our binomial formula. So B equals, we have C, we have 7 events, 5 were favored, times, and then we take our first probability, which is 1 over 6 to the power of 5, and then times Q, which is 5 over 6 to the power of 7 minus 5, which is 2. So I'm going to go ahead and erase that, just put 2. Okay, so now I'm going to put this in my calculator. First, I'm going to start with my, that's another thing I don't like in the way. I'm going to start off with my combination. So my combination is 7, 5. I hit enter, and that gives me 21. So I can have the same numbers again. So B equals 21 times 1 6 to the power of 5 times 5 6 to the power of 2. So I'm going to go ahead and put that 21 times, I don't think I need to put the parentheses, to be honest, 1/2 to the power of 5, get out of here, times 1/2 to the power of 2. I can enter, and it gives me 0.1, oh, it's not 1/2. Oh, no wonder, I was like, why did I get the same number? Times it's 1 6, 1 over 6 to the power of 5 times 5 over 6 to the power of 2. Enter, and we're rounding to the nearest thousandth, so it's going to be equal to 0.0018, so we'll round to 2. All right, the next one, it says a hiking club plans to go camping in a state park where the probability of the rain on any given day is 5/8. What is the probability that it'll rain exactly one of the 3 days they are there? We're rounding to the nearest thousandth again. So the number of events, well, we're going to stay there for 3 days, so we have 3 events. Okay. We're wondering, what's the probability that it'll rain exactly 1 day? So our favorable event, I believe, what do we do a favorable event with? I think it's an R. Let me just double check that. Yeah, it's R. Is 1. They do give us the probability. They tell us that the probability of it raining on any given day is 5 out of 8. So 5 out of 8 is our probability. And then our not rain, so if 5 out of the 8 days it's going to rain, that means that 3 out of the 8 will not rain. Okay? So then from there, I'm going to go ahead and put it into my binomial theorem. Okay, so we have a combination of 3, 1, because we're staying there for 3 days and we want it to rain 1 out of those 3 days. Okay? So then we have a probability, so we multiply times 5 over 8 to the power of the favorable events, which is R, so to the power of 1, and then times 3/8 to the power of 3 minus 1, which is 2. Erase that. Instead of 3 minus 1, I'm going to put it 2. So now, first I'm going to find the combination. So we press functions, we find the combination. We have 3, comma, 1. And I hit enter, that gives me 3. Okay, so the probability support here is B equals 3 times 5/8 to the first power times 3/8 to the second. So I go ahead and put that in my calculator. We have 3 times 5/8 to the power of 1, out, times 3/8 to the power of 2. Enter, it gives me 0.264. That would be my probability. Alright, the next one says if the probability of the Islanders will beat the Rangers in a game is 1 to 4. Okay, so they already give us a probability here. So the probability is 1/4. Then it says, what is the probability that the Islanders will get exactly 3 out of 3 games? Okay, so the number of events is going to be 3, and the number of favorable events is going to be 3 also, because they want them to win all of the games. Against the Rangers, round to the nearest 1,000. So if the probability of winning is 1 out of 4, then the probability of not winning is 3 out of 4. It's the other 3 leftovers. Okay. So I'm going to go ahead and put this in the formula. So my probability, my binomial probability, is C, and then we're going to do 3, 3 times 1/4 to the power of 3, and then the Q is going to be 3/4 to the power of 0. Okay, and the reason it's power of 0 is because we do 3 minus 3. Sorry, I kind of skipped this step. So I'm going to go ahead and put all of this in my calculator, starting with my binomial. So it's going to be 3, 3. I hit enter, that gives me 1. So B is equal to 1 times 1/4 to the third power times 3/4 to the 0 power. So I'm going to put that 1 times 1/4 to the power of 3. I don't know why I put the parentheses this time. Times 3/4 to the power of 0. And I hit enter, and so the probability of this to the nearest 1,000 is going to be 0.01, and that 5 is going to round to a 6. So that's to the nearest 1,000. Right, the next one. So here it says, during a single day at a radio station, the probability that a particular song is played is 1 out of 5. So my probability is 1/5. So right away, I'm going to go ahead and do my probability of not playing the song would be the other 4 of the 5. Okay. So what is the probability that this song will be played exactly 3 days out of the 5 days? Okay. So the number of events, well, we have 5 days. And the favorable events, so R, we want it to be 3 out of those 5 days. Okay. So I'm ready to plug into my formula of my binomial formula. Okay. So we're going to do a combination of 5, 3. And then from there, it is going to be 1/5 to the power of 3 times Q, which is 4/5, to the power of 5 minus 3. Okay, in that case, it's going to be 2. So I'll go ahead and write it down right now. So B equals, I'm going to go ahead and put my combination of 5, 3. So 5 and 3. Enter, that gives me 10. So then this is going to be 10 times 1/5 to the third times 4/5 to the power of 2. Because 5 minus 3 is 2. So I'm going to go ahead and put all that in my calculator. So 10 times 1/5 to the power of 3. And then get out times, and the other one's 4/5 to the power of 2. And that is going to give me b equals 0.0512. So if I round 3 decimal places, it would just be 51. Okay, the last example. So here it says Mr. and Mrs. Doran have a genetic history such that the probability of a child being born to them with a certain trait is 1 out of 4. So my probability right here is 1/4. So now the probability of not is going to be the other 3 out of the 4. Okay, so if they have 7 children, so then that means the number of events is going to be 7 because they're having 7 kids. And the favorable events is that exactly 6 of the 7, so then R is equal to 6. Of the 7 children will have the trait, round your answer to the nearest thousand. So we do the same thing again. Our binomial theorem, we're going to do a combination of 7, 6. And then we take our probability, which is 1/4, and we put it to the power of the favorable event. So 1/4 to the 6th power times 3/4 to the power of 7 minus 6. Okay, so I'm going to go ahead and put the 7, 6 in my calculator. So 7 and 6. Enter, that gives me 7. So b equals 7 times 1/4 to the 6th power times 3/4 to the 7 minus 6 is going to give us 1. So I put that in my calculator exactly the way I see it. So 1/4 to the 6th power times 3/4 to the power of 1. We hit enter. This gives me 0.001. And that's it. Thank you guys. Bye.